So at the last video, we have talked about the using the binomial distribution to test whether there is evidence of a decrease in support for the citizen party. So we have tested at the 10% significant level, and we finally have concluded that if, because there are 3 of these 20 voters, the final probabilities was 0.0604, which is smaller than 10%. For this reason, we have accepted the alternative hypothesis, which is H1, and that mean is smaller than 1/3. Right, so now let's just assume that this was not 3, but this was, in fact, there were exactly 4 of the 20 voters. 4 of the 20 voters said that they would vote for the citizen party. So the probability would be different, right? So the probability for x is smaller or equal to 4 is probabilities of x is smaller or equal to 3 plus probability of x is equal to 4, which is this, and this will be equal to 0.1515, which is bigger than 10%. Now this is bigger than 10%, so in this case we are accepting H0 instead of H1, and that mean hasn't decreased yet. So here we accept HO. So there's a concept in hypothesis testing called critical region, which is the region where if the numbers of the numbers of x fall into that region, we will decline H0 and we will accept H1. So in this case, if x is smaller than or equal to 3, we will accept H1. So let's just say if x was 2, so the probability of x is smaller or equal to 2 is also smaller than 10%, which is when we accept H1. So similarly for x equal to 1 or x equal to 0, but now if x is equal to 4, which is outside of this region, so x is equal to 4 is not in this region, we accept H0. So the critical region is, say, the region where we decline the null hypothesis, which is where we decline HO and we accept H1. Decline HO and we accept H1. It is the critical region, and in this example, if x is equal to 0, 1, 2, or 3, which is x is smaller than 3, is smaller or equal to 3, sorry, then this is the critical region.